Hello, welcome to this video. Today we're going to look at a different type of presentation. Instead of taking an actual real life whiteboard and writing on it, we're going to do a whiteboard on a computer, but that shouldn't affect us. So today we're going to look at you can say the formula for the derivative of a certain function. And then next video, we're going to look at the formula for the area under a function between it and the x-axis between two bounds, and when the function is above the x-axis, and we'll show that why that is equal to the integral between the bounds of the function, and we'll show that in a pretty mathematical and algebraic way. And then the third video will be about the length of a function between two bounds. So first of all, let's start with really the derivative. So what is a derivative? Well, that is simple. You take any function, such as this one, pick a point on it, and then you draw a line tangent to the function at that point. And then the derivative of the function at that point is defined as the slope of this line. And the derivative generally of a function is a derivative of a function f of x. We write like this, f prime x. This will be the general formula for the slope of any tangent to the function at any point x. So here is what we are going to do. We're going to use a very simple trick. We are going to take another point, not really related to our original one, that is also on the function. So we'll take this point, and we'll call this point A and this point B. Now, what we will do is draw a line through both of those points. And we know the formula of the slope of a line. So if we know 2 points on it, so here A and B, we know it's going to be y of A minus y of B divided by x of A minus x of B. Now, here is what we are going to do. We're going to take B and take it closer and closer, move it on the function closer and closer to our point A. So if B were suddenly here, so we'll call this B prime, the next point of B, then the line would have been like this, something like this, and the slope would change. And as B moves closer and closer, you can imagine that the line AB will approach the line tangent to A. And then we will let the distance between A and B go, and you could say approach 0. And so can be exactly 0, because then we'll have to divide by 0 in our formula here. So we will let their distance approach 0, which is what is known as a limit. So we will call their distance h, specifically their distance between their x values, meaning that xa minus xb will approach negative h. So this will be negative h. And on the top here, what we will have is f of x of a, which we'll call x, minus f of x of b, which we know is x plus h. So we'll move the negative to the top here and arrange things to get f of x plus h minus f of x all over h. Now, h here approaches 0. So we can just write this for any h, and we can say that h is equal to 0, because then we'll get 0 over 0. So what we will do, like we said, is let h approach 0 and take a limit, which I hope you're familiar with. And that is what we got. The limit as h approaches 0 of f of x plus h minus f of x all over h. Now that we've established the formula for the derivative, let's erase the board, leave this formula, and look at a couple examples. So let's see. Let's look at, first of all, a simple function, a constant function. F of x is equal to, say, 5. If we put that, so first of all, let's see. If we graph that, we will get a line, we'll get a line that's like the x-axis. So the tangent to it will be the same function, you can say. Yeah, you can imagine this. So the slope will be 0, which is what we expect from our formula. So let's see. We have f prime of x equal to the limit as h approaches 0 of, now let's see, f of x plus h is 5, because f of any x is 5. F of x is also 5. And then we divide it by h. So this 5 minus 5 is obviously 0. And then if we take, and then the limit doesn't matter. 0 over anything is equal to 0. And then we don't need to take the limit of it anymore because we don't have any h left. So, and that is what we expect. So the derivative of a constant function, for example, 5, will be 0. Let's look at another example. So let's take something a bit more challenging. How about a parabola? Let's do 2x squared. What will we get? Well, let's see. We will have f prime of x is equal to the limit as h approaches 0 of, now let's see, f of x plus h is, so first of all, I'll take a 2 out because there's going to be 2 times this squared minus 2 times this squared, so might as well take it out. A 2 out. Now, x plus h, that entire thing squared, is x squared plus 2hx plus h squared. And then f of x will just, this will just be minus x squared because we already took a 2 out. Then this entire thing is divided by h. Now, let's simplify. So this cancels, we'll take this 2 out of the limit to get 2 times the limit as h approaches 0 of, okay, now let's see. We have left in here 2hx plus h squared over h. Now h will cancel with this, and we'll get 2x. Then h will cancel also with this, but because it's a square, we're left with h. But now let's see. H is approaching 0. But the thing is, here, as long as we plug in whatever we approach and we don't have any problems, then we can just plug it in. So here, for example, we couldn't have plugged in because we would have got 0 over 0. But here, we can plug in h, and this plus h will just disappear, and we'll get 2 times 2x, which is 4x. And that's our answer. So now let's look at something a bit more tricky. So let's see. Let's erase this. And instead of looking at 2x squared, let's look at something more general. How about x to the n power? So let's see what will be our derivative. F prime of x. So let's take this crazy limit. Now, we have the limit as h approaches 0 of, let's see. Okay, so we already have x plus h to the n. But if you don't remember, we already derived the formula of x plus y to the n on this channel. And the factoring will be x to the n plus, it should be n choose 1 times x to the n minus 1 times h, and so on and so forth. And the rest of the things are things that are divisible by h squared. So something times h squared. And keep that in mind, that's important. And I want to simplify this. So simplify this a bit. So n choose 1 is, if you remember, is really just n. So n times x to the n minus 1 times h. Then plus h squared times all that stuff. And then we subtract f of x, which is just x to the n. And then all of that over h. Now, x to the n minus x to the n cancels. We have a h here cancels. Then we have this h squared divided by this h will cancel just this square. So we will get the limit as h approaches 0 of n times x to the n minus 1 plus h, remember this is h, not n, times all of that stuff. Now, let's try and see if plugging h equals 0 will give us any problem. Okay, putting in h equals 0, we'll have 0 times all of that stuff will cancel out, and it will be just left with n times x to the n minus 1. That's not a problem, so we will just write down what we have after plugging in h is equal to 0, which is n times x to the n minus 1. And that's the formula for that's how we derive the formula for the derivative of a power like this. And we can think of this as if we have x to the n, our n jumps to the front, and we get another minus sign at the power to get our derivative of n times x to the n minus 1. And then you can imagine performing this derivative again will give you n times n minus 1 times x to the n minus 2, then n times n minus 1 times minus 2 times x to the n minus 3, and so on and so forth. And you can imagine, and then you can say that even though this is pretty much not helpful. It's still a nice thing to know that the nth derivative, which we'll write like this, with this n, symboling that there are n derivatives being performed on this, is equal to n times n minus 1 times n minus 2 all the way on to 1 times x to the 0, which, because x to the 0 is equal to 1, and the rest, and then the rest, 1 times 2 times 3 all the way on 2 times n, is the definition of n factorial. So a cool thing to know is that the nth derivative of x to the n is n factorial. Okay, I think that is enough. If you like this, please subscribe to my channel. I'll be uploading more things like this in the future. And finally, that's it.